So moving on, the next section, and this is not 5, is we're going to be talking about the nth roots, and we're going to be simplifying more radicals. So when we find the square root of a number and squaring the number, those are inverse operations of each other. So basically what that means is if we take the square root of 4 and that equals 2, we know if we go the other way, that 2 squared is equal to 4. So that is what we mean by inverse operations. So you have explanations there in that chart for third, fourth, fifth, even higher than that. But ultimately, when we talk about the definition of an nth root, it means that for any real number a and b and any positive integer n, if a to the n equals b, then a is an nth root of b. So if we have 2 to the third equals 8, then that means that 2 is a cubed root of 8. Okay, and we're going to now, we've only really seen square root, so you have no number written outside there, but now we're going to start to see the numbers change. So the little number on the outside, that's called the index. The sign is obviously the radical sign. And the number underneath is called the radicand. All right, and examples of nth roots. I could say the square root of 25. Well, the square root of 25 is 5. Okay, so the square root of 25, what that means is that indicates the principal root of 25. And what we mean by the principal root is that's the non-negative root. So non-negative. If I tacked a negative in front, like the negative square root of 25, well, that would give you a negative 5 for an answer. So when I throw a negative in front of the square root, what that indicates is that indicates the opposite of the principal root. So if the principal root is the positive, then this is going to be the negative. Opposite of principal root. And then if you see plus or minus thrown in front, well, then you're going to give both answers, plus or minus 5. So they want both the principal root and they want the opposite of the principal root for that. Okay, so now as we go through these, again, you might still see square roots, and then you're going to also, though, see other numbers as well. So let's practice with the square roots first. So we're going to simplify plus or minus square root of 16 x to the 8th. So we know we have a plus or minus in there. So what you're going to do is you're going to think to yourself, okay, well, 16 is what squared? So that's 4 squared. And x to the 8th is what number squared? Well, that's x to the 4th, because 4 times 2 is 8. So the square root of this, plus or minus square root of 16, which is 4, and the square root of x to the 8th is x to the 4th. And there's your final answer. Ultimately, all we did is we did 8 divided by 2, and that's where that exponent came from. For this one, we have negative out front, and then we have a 4 here. So all we got to do is just divide that whole entire parentheses. You're not doing anything with it, just leave it alone. And then we're going to raise it to the second power. It doesn't say expand it out. It's just telling you to just simplify. All right, now we're moving on to fifth root. So you have to think to yourself, all right, I'm taking the fifth root of every single number. So I need the fifth root of 243. So what multiplied by itself 5 times equals 243? And that would be 3. For the 10 and the 15, just like on the first page where we had just divided them, you're doing the same thing. So 10 divided by 5 is 2, and 15 divided by 5 is 3. So you get 3x squared y to the third. Now for number 4. You have a negative underneath, so this is not a real solution. We know that this is imaginary. But just to solve it, because we have done this already, you would get plus or minus 2i for that one. Okay. Now for 5, we have the third root of negative c to the 6. Now, in the past, usually you can't take the square root of a negative number. That's fine. You can't take the even power of a negative number, but you can take the odd power of a negative. So I'm going to actually break this up to be the third root of negative 1 times the third root of c to the 6th. So the third root of negative 1 is negative 1. And then with the 6, you just divide by 3, so you get c squared, so you get negative c squared for that one. For C, or for 6, you have 36 times this times this. So treat each one separate. Square root of 36 is 6. Square root of x to the 8th is x to the 4th, because you divide by 2. And the square root of y plus z to the 4th would be y plus z to the 2nd. So the exponents, you divide by the value, the index on the outside. But for the numbers, you've got to figure out what they are, whether they're perfect cubes, raise it to the 4th power, 5th power, whatever it may be. Now, the extra extension here, it says when you find an even root of an even power and the result is an odd power, you must use the absolute value of the result to ensure that the answer is not negative. But this only applies. We have an even root put together with an even power, and your answer is an odd power. So if we're taking the square root of 36y to the 6th, the root is 2, because we're taking the square root. The power that we're working with is 6, and then our resulting power would be 3, which is an odd number. So this is where the absolute value comes in. So usually we would just write 6y to the 3rd. But given that that is now a odd number, you have to put the y to the 3rd in parentheses like that. So the 6 is fine, but you do need to put the y to the 3rd. Now for 8, if you factored this, you would get z plus 4 squared. It's a perfect square. So the root is equal to 2. The power is also equal to 2. And then the resulting power is equal to 1 when we do 2 divided by 2. So that's odd, which means that usually we would just write z plus 4. But given that it's to the first, you have to put absolute value symbols around it because the result power was odd. With number 9 here, the 5th root of 243 we know is 3 from above. We have the root is 5. The power is 15. Okay, and then the resulting power would be 3. Now, keep in mind though, it says even root, even power.